use variation of parameters to solve the given system. So in to use variation of parameters method, here's the steps you need to do to solve for the solution. So first you need to find a homogeneous solution, and then you need to find non-homogeneous solution. So for final solution, you just add these two together. Okay, so I'm sure that you already learned this, and then I'm not gonna spend time going over it, but I will walk you through the problem step by step. Okay, let's get started. So first find the homogeneous solution part. So the first step is you need to rewrite this. Oh, I skipped a step. Rewrite this in terms of A minus lambda I. Okay, so what is A? Let's call this matrix A, and then subtract it with lambda. That gives you this matrix. Okay, and then you need to find its determinant, which gives you this one. So distribute this out, simplify it, set it equal to 0, and then solve for lambda. It gives you repeated eigenvalues. Now it's time to find eigenvector. So when lambda equals 1, plug it into A minus lambda I. That gives you this matrix augmented with 0. From the first equation, solve for k1, I got negative k2. If I choose k2 1, then k1 is negative 1. Vector k is negative 1 1, and vector x1 is negative 1 1 e to the t. So since you have repeated eigenvalue, you cannot use any other lambda to plug it into A minus lambda to solve for eigenvector. So what you need to do is to take this matrix augmented with what you just found for vector k. Okay, so initially you augmented with 0, now you augment this with negative 1 1. Okay, and for this one I call it k1 k2. Now for this one I'm going to use different variables, which is p1 p2, okay, to differentiate with this one. Okay, so after I have this matrix, use the first matrix. I have 2p1 plus p2 equals negative 1. Solve for p2, I got negative 1 minus 2p1 all over 2. If I choose p1 0, then p2 is negative 1 half. Then my vector p is equal to 0 negative 1 half, and my vector x2 is equal to this k times t e to the t plus p times e to the t. Okay, so that is my second solution. Now let's put them together for the non-homogeneous solution. So it is equal to c1 times vector x1 plus c2 times vector x2, okay, which is this. Okay, now let's find the non-homogeneous part. So similarly, like A minus lambda I, now you need use a homogeneous solution and put it into a matrix. Let's call this matrix phi of t. Okay, so what is phi of t? So from homogeneous part, exclude c1 and c2, then put the rest into the matrix. Don't forget to multiply by the function in terms of t here. Okay, so you have multiplied this, you have negative e to the t, positive e to the t for the first column. Second column, multiply this out and add them together, it gives you the second column. Okay, and then you need to find the determinant of phi of t, which gives you 1/2 e to the 2t. Sorry for the messy here, because I realized before this I realized that I made a mistake, and then I just erased them and then redid it, so I still have what left over. That sometimes you can see it. All right, so once you figure out the determinant of phi of t, then the next step is to find its inverse. So it is equal to 1 over determinant times this vector. So in upward diagonal line, you are going to multiply by negative 1. So I have negative e to the t, positive t e to the t. For downward diagonal line, you are going to switch their positions. Okay, so bring this up, bring this down. Okay, which I have this vector multiplied by 1 over the determinant. It gives me this vector. Okay, all right, let me double check one more time. Okay, so you have negative 1, negative t, negative t, negative t, negative t, negative t. Oh, okay. Now it's time to find u prime, which is equal to inverse phi of t times f of t. What is f of t? F of t is what left over when you have at the beginning of the problem you have vector x prime equals something times vector x plus something. That something is your f of t, which is this one. Okay, so a little note here: do not switch the order here, the position of these two matrices, because multiply matrices is different from multiply a number or variable. If you switch their order, it will give you a different answer. Okay, so if I multiply these together, it gives me this matrix. Simplify this, it gives me this one. Okay, and then phi u of t, which I integrated u prime of t. Okay, integrating this one, it gives me this one. And let's take a look at the integral of 6t e to the negative t. I worked it out over here. So let's use integration by part method. Let u equals 6t, du equals 6, dv equals e to the negative t, v equals negative e to the negative t. Okay, so I'm pretty sure you know how to do the integral, guys. All right, and then this and this is easy. Okay, now let's find vector x of p, which is non-homogeneous solution, and it is equal to phi of t times u of t, which is this vector matrix. Okay, so again you have this order, and do not swap the order when you multiply matrices together. Work this out, you will get this, and you after you simplify it, it gives you 4, negative 7. Okay, then your final answer is equal to homogeneous solution plus non-homogeneous solution, which is this one. Okay, so some you may realize that this answer is different from the book or from what you worked before. Okay, why? Because up here I may have a negative 1 1 vector, or I may have positive 1 negative 1, and similarly over here it really depends on these two in the order. Okay, so if you put this in front for the first column and take this, put it down for the second column, it just gives you a different x of p. Okay, so that's why, so if you follow me, this is the correct answer for this order. Otherwise you will get a different answer corresponding to your order. Okay, that's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.